Okay, I'm going to show you how to do how to set up your truth table and how to make sense out of it. Hopefully, all right. So hopefully it's going to work. I've actually recorded this once and I was unhappy with my recording, so I'm going to do it again. And anyway, so the first thing, let me just go online and so here's course content, and let's see. I'll put this over here. Yeah. 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 Okay. Perfect. All right. So website. This is the assignment sheet, which hopefully you've seen, and that's where your assignment is, of course. And if we open it in Word, actually I think I already had it open. So we have this. One of the things I did, I put this template on here for you. So I went ahead, expanded it, printed it out, put it in landscape view, and so I've got it down here, and let me show you what that looks like. So here are the letters I have to do, and then here is here's what it looks like. So I'm going to shrink this, not shrink it, but make this smaller. All right, and then so I'm going to go through. I'm going to do S. So I look up here. So I'm going to do the characters S, T, U, V, W. Those are my 5. Okay? So I put in S. I used a little highlighter. I put in T, put in U, and V, and W. Now I went back on S and I looked at all the segments, and I had 1, 2, didn't have 3, but I had 4, 5, 6, didn't have 7, but I had 8, and then I had these middle 2, 9, 10. And you can read those numbers. I don't know, for some reason they're a little off here. Let me just, yeah, maybe that's a little better. Maybe not. And then for the T, I used 1, 2, 11, and 12 down the middle. And for U, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. And for V, 7, 8, 13, 16. And for W, it was 3, 4, 7, 8, 15, 16. And when I stared at them, I realized, much to my horror, that that the only segments I didn't use was segment 14. None of the characters have 14, and the decimal point, of course. So I have to generate 15 of the 16 inputs. I have to generate inputs for. And no segment was present in all characters. If you have a segment present in all characters, you don't even have to do the K-map, because the K-map is going to be the constant 1, and you just have to hook that segment up to your positive voltage. But I don't have one like that, and that's because T had nothing down either side and only down the middle. That's the one that messed me up. Okay, so now that I have the segments, now I can generate my truth table. Now, the way to do the truth table is, I have 3 independent variables, A, B, C, D, and I have my 15 functions across the top I need. I'm not going to put 14 in because it never needs to be lit. So that can just be grounded or left disconnected, really. So I have my 3 independent variables, and that gives me 8 rows. 0, 1, 2, 3, 4, 5, 6, 7. I have function 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16. 15 functions, missing 14. And then I took these numbers, and so I know for the first row I have to put in 1, 2, 4, 5, 6, 8, 9, 10. Okay? 1, 2, 4, 5, 6, 8, 9, 10. And for the next row, I needed 1, 2, 11, and 12. So 1, 2, 11, 12. And the next row, I needed 3, 4, 5, 6, 7, 8. In here, 3, 4, 5, 6, 7, 8. and the next row I needed 7, 8, 13, 16, and finally 3, 4, 7, 8, 15, 16. So I put ones in all those places. Now everywhere I don't have a 1, then it would be a 0, and you do need to put those zeros. You probably should put those zeros in just to keep yourself straight. But if you leave them out, remember where you don't have where it's blank, it's a 0. Okay, and then I know my last 3 numbers. I only have 5 characters: S, T, U, V, and W, and then I have don't care, don't care, don't care. So these bottom 3 rows are all don't cares. So now I'm going to generate 15 3-variable K-maps to get the hardware I need for each of these functions. All right, and I did them. I actually really struggled. I'm going to assume I'm going to do. I'm going to assume that I'm going to do SOP function. So my final answer is going to be a nan form. All right. So here are my K-maps, and you can see I kind of struggled through them a little bit. So here's number 1, and you can see where I just took this right off of. It comes right off of my K-map. Let's see. I think I can blow this up. Yeah, let me do this real quick. Okay. Yeah. All right. So now, so you can see. So the first row, it's going to be this down here. This is my function. So I'm going to have 1, 1, 0, 0, 1, don't care, don't care, don't care. All right? So that would be 1, 1, 0, or 1, 1, switch the rows, 0, 0, 0, don't care, don't care, don't care. All the maps are going to have these 3 don't cares. Remember to switch the row over here, though. All right? And then the number 2, it's just going to be 1, 1, 0, 0, 0, don't care, don't care, don't care. 1, 2, 0, 0, 0, don't care, don't care, don't care, don't care, don't care, and so forth. Do that for all of them. For 3, I had 0, 0, 1, 0, 1, don't care, don't care, don't care. So 3, 0, 0, 1, 0, 1, don't care, don't care, don't care. All right, and then I just did the take out the SOP forms. So for this one, the SOP form was A prime, C prime. Here it was A prime, B prime. Here it was I had this and this, so it was A plus B C prime. Yeah, where is it? A plus B C prime there. I think I did it another place too. Yeah, and then I just kept working. And I did 3 again because I messed it up so bad over there. Well, I did the POS form there. Anyway, here's a 4, I guess, or no, here's A B C prime. Yeah, and then there's number 4, C prime. Number 5, A prime, C prime. Number 6, A prime, C prime, that's the same. So 6 and 5 are the same, and there were several. If you look at, where's my thing? If you look at 1 and 2 are identical. Yeah. So 1 and 2 are identical, so they're both A prime, B prime. And then 4 and 5, no, 4 is different. 5 and 6 are the same. 7, let's see. 9 and 10 are the same. 11 and 12 are the same. And that's it. Okay, so 11 and 12 were pairs. 9 and 10 were pairs. 5 and 6 are pairs. And 1 and 2. So I had 1, 2, 3, 4 that were paired up, were identical, and I don't think any of these others paired up with anything else. Okay, so when they're the pairs, you can just tie those pins together and drive them with the same hardware, the same circuit. Okay, So now I have a total of 15 K-maps that I've simplified in nan form. Now, I'm sorry, in SOP form, because I'm going for nan. Now what I did next was I went ahead and drew my circuit. Probably shouldn't have, but I did. And one of the things so here's my chip with a bunch of pins. I think really it's 1 through 8 and then 9 through 16. So 8 should be over here, I guess. And this should go down here anyway. But don't worry about that. All right. So for pin 1 and 2, I had one gate. Now I just used this AND gate with A prime and B prime going in. Now remember, if I want to make this a NAND gate, then how am I going to do this? Well, so A prime, B prime. So we'll do one inversion, and we'll do a second inversion. So we'll bring this in here. Yeah, it gets a little screwy. So let's make sure we do this right. Okay, so it's a little confusing, but let's say for the first two, we just have A prime, B prime. Okay, so that's an AND gate. A prime, B prime. Now, how can we turn this into an AND gate? Well, it's a little confusing, but the easiest way to do it is to do it graphically when you just have this single AND gate. And what you want to do is you want to here's your line. You're just going to go ahead and put 2 bubbles on this line. The one bubble up here, which is always legal, right? The one bubble up here just makes this a NAND gate, and the bubble down here you can just turn into an inverter. So basically, we're going to invert it, or if you want, you can even make this another NAND gate with the inputs doubled. And so we have A prime, B prime coming in to a NAND gate, and it goes through an inverter or a second NAND gate if you want. So doing this in NAND gates causes a little problem. It makes us basically double invert the output. But there's nothing you can do about that. That's just how it is. So to get the solution, do a NAND gate and an inverter. So it's probably easier to do this one. Again, looks like this. A prime, B prime, bubble here, and an inverter. Doesn't matter if the bubble's there or there for an inverter. It's the same thing. The symbol. These are entirely equivalent. So you just swap them out. All right. But we do have to have this inverter to make this work, because it's only one layer. All right, so that's our NAND, and that's going to be for F1 and F2 because they're the same. As you can see from the truth table, again, if we look at that, you can see we have a 1 1 0 0 0 don't care 1 1 0 0 0 don't care. So they're the same. All right, so that's the gate. And then all we have to do then is we have somewhere we have our display, which basically looks like this. So here's our chip, and you can see we got a bunch of pins. 1, 2, 3, 4, 5, 6, 7, 8. I think there's 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, there's 9 pins. So there's 18 pins. There have to be. That's right, because you have a common, and then you have 17 pins. Yeah, but that isn't right either. So let's see. I think maybe there's 1, 2. I can't see these things. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so 9, 18, and there's 17. So yeah, so there's. But 2 of these are tied together. This is a little screwy. This is a little goofy. I have another set of these chips and like this, and this one's a little more, but it's got the same number of pins. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so they have 18 pins, but there's 17 segments and a common, and so the common has to be tied to power, and then the segments have to be grounded to turn them on. Actually. All right, so anyway, so now we have pin This would be pin, we'll say segment, whatever the pin is for segment 1, whatever the pin is for segment 2. And we're just going to connect this this business right to 1 and also to 2. And that's what we have to do for all of them. You basically, when you just have a single AND gate, you're going to have to just put 2 bubbles on it and then make one of the bubbles into an inverter and the other makes this an AND gate. Hopefully that makes sense. So that's the basic idea. So for this problem, I actually had to do 15 K-maps, and that's what it took. 15 K-maps, and that's the only way I could make it work. So hopefully you'll get by with fewer K-maps, and if you only have a single AND gate, I'd like you to do it in NAND. I'd like you to change that AND gate into a NAND gate. But remember, that's super easy. All you have to do that, if you wind up with a single NAND gate, all you have to do to change it. Again, you've got some kind of NAND gate, maybe even have ABC into it or whatever. So here's your output going into your chip. Maybe that's pin 6 or who knows what. You put a bubble here and you put a bubble here. The bubble there just turns into an inverter. That makes this an AND gate, and that justifies putting a bubble there. Okay? All right. So I hope then you can take once you have when you look at the hardware, one of the things you're going to be able to see, and I'll show you with my little schematic here, hopefully. Maybe I won't. Let's see, where did it go? Yeah. So when it was all said and done, I wound up with 4 pins that have the shared input. So 1 and 2, I could just connect those pins together and drive them with 1 gate. 5 and 6, same thing. And where's my truth table? And 5 and 6, 9 and 10, and 11 and 12. Those were just jumpered. 11 and 12 jumpered, and 9 and 10 were jumpered. And 5 and 6, 1 and 2. And then there were some other places, like I had BC. This one was set up with BC going into A. So, let's see this one. Okay, so we had, this was for pin 16. So for pin 16, I had BC going into an OR gate, and it also had A. Now this one, I can just do my standard, right? I can substitute in, for the OR gate, an AND gate with bubbles on the inputs and 1 on the output. And then I still have my BC up here, and I have my A going in here. Now what I can do is I can slide this bubble up here and make that an AND gate, and I can take this bubble, slide it up, and make this A prime, and get rid of the bubble. So then I wind up with BC going into this NAND gate now, going into my output NAND gate, and A prime going in as well. Have to convert the A to an A prime. So that's how you convert this setup. And let's see. Okay, here I have A and B going into pin 7 through an OR gate, which looked like this. This would have been A plus B. Okay, all right. So what I do there is I put in my OR gate. I have A and B, and that's going into pin. What was that pin? For me, it was pin 7. All right. So now what I can do is substitute in an AND gate, substitute in an AND gate with bubbles and everything. So now I have an AND gate, bubbles on the inputs, bubble on the output, and then I can take these bubbles off and make that A prime, B prime. So now I have a NAND gate going in with A prime and B prime going in. And when you look around, you'll probably be able to share some terms. So in this case, my pin 13 was also had B and C going in. So then I just have to make this into an AND gate as well, which means I'm going to have an inverter here. Okay. All right. So using a little, so for these, you probably don't have to do the Morgan's laws. All you really have to do for most of these, maybe for a couple of them you do, but for most of them, you just have to use the graphical equivalent. Just use graphical techniques. Remember, you can slide bubbles. 2 bubbles will cancel. You can always add 2 bubbles. And you can always substitute for an OR gate, an AND gate with bubbles on the inputs and the output. For an OR gate, you can and for a AND gate, you can substitute an OR gate with bubbles on the inputs and the output. But you probably don't want to do that in this case. If you're doing AND. If you're doing NOR, then that's what you would do. You would be substituting in the OR gate for an AND gate with bubbles on everything. Okay, so I would suggest for when you only have when you don't have the full expression with multiple AND gates going into a single output OR gate, it's easier to do it graphically, because you may get a little confused if you try and do it with switching algebra by doing the Morgan's law with the double inversion. Because I'll show you an example. So let's take AB. So we had that AB gate, AB, and an AND gate. That was driving our input. Now if we want to write that AB, and we want to do an inversion and do a double inversion, how does that work? How do we partially expand that? Well, you really can't, because if you try and put this in here, now you're going to get A prime plus B prime. Well, that's an OR gate. It's not going to be a NAND gate. So forget it. Now, what you can do, well, it's much better to do the graphical when you just have a single gate like that. It makes more sense. Okay, I think that's it. Hopefully that makes it pretty clear. I'm going to stop this, and I'm going to post it so you'll be able to use it to help you.